Your production database suddenly starts rejecting queries at 2 a.m. Your on-call engineer wakes up to 47 Slack alerts. By the time they'd gathered logs, restarted services, and written a post-mortem, 4 hours have vanished. But what if an AI agent had already detected the anomaly, fixed it, and left you a summary before your alarm clock even rang? AI agents are autonomous systems that perceive their environment, make decisions, and take actions across multiple tools without needing you to babysit every step. Unlike a chatbot that answers one question and waits, an agent observes what's happening, reasons about what to do next, takes action, checks the result, and loops until the goal is solved. Think of it like a delivery driver with a clipboard and a radio. The driver receives a destination, checks the map, radios dispatch asking which way to go, gets an answer, drives 1 block, reports back if the road is closed, and adapts in real time. The core engine is the agentic loop: observe state, call an LLM to plan the next move, execute that action, capture the result, and feed it back in. A debugging agent watches a failing test, asks GPT for what to try, applies the patch, runs tests again, and keeps looping until everything passes. But an LLM alone is just words. The magic happens when you bind real tools, APIs, code interpreters, databases, file systems. An agent retrieving stock prices doesn't hallucinate numbers. It's wired to a live market API and learns to call get_stock_price with the right syntax. Agents also need memory. As a document processor works through a 50-page report, it remembers tables extracted from page 1 while analyzing page 10. Without persistent state, it would reparse and forget everything constantly. For hard problems, one agent isn't enough. A research agent might spawn a web searcher and a code analyzer running in parallel, then merge their results. This hierarchical orchestration scales work without creating a single bottleneck. When things go wrong, and they will, agents need deterministic fallback. If an LLM generates a malformed SQL query, the agent catches the error, rolls back, reformulates using a safety template, and retries. LangGraph, from the creators of LangChain, is the gold standard for building agentic loops. It's a state-machine framework that makes reasoning loops explicit, testable, and debuggable. You define nodes for each decision point, edges for transitions, and LangGraph handles the orchestration. AutoGen, from Microsoft, takes multi-agent conversations seriously. Agents are personas that communicate, critique each other, and solve problems collaboratively. It's built for scenarios where you need specialized sub-agents debating before committing to action. CrewAI is the newer player, emphasizing role-based agent teams with built-in memory and tool sharing. If you want to feel like you're assembling a crew of specialists, this abstracts away a lot of boilerplate. Anthropic's tool use research, open-sourced in their models and SDKs, shows how modern LLMs are being trained to call functions reliably. The patterns trickling down into production are becoming the standard. For incident response, agents shine. Detect an anomaly on your monitoring dashboard, gather logs, restart services with predefined rules, and write a post-mortem summary, all while you sleep. For code review, an agent can scan pull requests, run linters, suggest fixes, apply commits, and only ping humans for architectural decisions. No busywork, just expert collaboration. Data pipelines orchestrated by agents detect schema changes, regenerate ETL mappings, and roll back on failure instead of exploding your alert system. Customer support agents route inquiries to knowledge bases, log tickets, escalate when confidence drops, and never let a customer fall through the cracks. Every interaction is logged and traced. These aren't hypotheticals. Teams are shipping these today. But here's the honest truth: agents are not always the answer. If your task is simple, deterministic, and runs once a month, throwing an agentic loop at it is overkill. Agents introduce latency, cost per token, and debugging complexity. You're trading real-time responsiveness for autonomy. Agents also hallucinate and make mistakes. An agent might confidently delete the wrong database because it misread a variable. You need guardrails, approval gates, and rollback mechanisms. They're powerful, not infallible. Start small, wrap one internal tool, let the agent make low-risk decisions, observe its behavior, and expand from there. The teams winning right now aren't the ones treating agents as magic. They're the ones treating them as a new class of engineering problem that requires the same rigor as any production system. Bookmark LangGraph if you want explicit control and testability. Grab AutoGen if your problem is fundamentally multi-agent. Try CrewAI if you want a faster path to a working prototype. Read Anthropic's research if you want to understand the foundation. Then build something small, measure it, and iterate. The next wave isn't coming, it's already here. The question is whether your bookmarks are ready. Subscribe to stay ahead of the agent revolution.